Here, we introduce the visual analytics system Semantic Prism aimed to visualize computer health status in a global organization. Semantic Prism is a web application built using Adobe Flash that can run on almost any web browser. Semantic Prism enables users to get an overview of the whole world, locate problematic areas, and drill down to investigate individual computers. On the map, offices are plotted as color-coded dots to represent the highest policy violations in the office. The user can immediately identify the office on the map with computers affected by virus. Now, at 2 p.m., we can see there is one office affected, Headquarter 2, colored dark red. Zooming in on the map allows us to see different levels of details of the office on 4 semantic zoom levels. The first level shows offices with their highest violated policy. The second level uses a horizontal color bar to show the percentages of computers in different status, including being offline. The third level presents the time series curves of individual offices that show the total number of online computers and the different policies. The fourth level visualizes the history of each computer as a colored bar. The color shades show the policy status. Filtering by policy 5, we can easily identify the problematic computers in this office. At this time also, we can see some black dots in region 25. Clicking on this region, we see a summary of all offices in this region. There may be a power outage, but more offices lost connections since it happened at 12 p.m. The problem is resolved at 4:15 a.m. the second day. Offices with computers having certain policy or activity flags can be highlighted by blinking dots on the map, with the size representing the number of affected machines in that office. As time passes, the number of computers violating policy 5 grows rapidly. Combining the information provided by the map, blinking dots, time zones, and heat map, the user is able to see and compare different dimensions of the data in one screen. We also check for activity during nighttime, and the results show no abnormalities. The time series curves graph present how the policies and activities change during the given period in the number of machines affected. We can switch to see ATM or workstations conditions. Since many workstations are turned off at night, we see a step function-like curve due to different time zones. The curve can be switched between logarithmic or linear layout. Here we see a big jump on the number of servers. Checking the regions curve, we found that the headquarters data center 5 added a lot of servers at that time. The user can choose to visualize different combinations of variables on the time series for further analysis. We use pixel visualizations to visualize IP blocks. In this visualization, one pixel represents a C block in the IP address. The colors of the pixels are determined by the number of computers with the selected policies or activities. Clicking on the pixel will bring up that level C block history. The number of connections grid visualization allows the users to inspect the maximum and average connections of all C blocks in a selected B block. Here, we can easily see several C blocks containing an abnormal number of connections at offline time. It seems that this is not related to any policy or activity. We hypothesize that these computers may be getting hacking attempts at night. The three main components in Semantic Prism, geotemporal visualizations, time series curves, and pixel visualizations with semantic zoom, allow for a thorough exploration of huge data from a global organization.